Here we are back for Environmental Science, Chapter 4, Lesson 2, on describing populations. With this, I hope that you are able to fill out your notes as we go along on this video, and then you'll be able to turn those in at the end. All right, describing populations. Individuals of the same species living in a particular area make up a population. We talked about that in 4.1. Now we're going to continue on with that as we're talking about our populations. The overall health of the population can often be monitored by tracing how its size changes. So if you can see in our picture here, we looking at China, India, Nigeria, USA, and Japan. And what it was, this one over here, the lighter blue or teal, whatever color you want to call that, that was the 2017 population. And based off of that and what it's been doing in 2100, you can see where the projected population actually might look like in those areas based off of what we know about size changes and the monitoring that many scientists have done. Population size may always increase, decrease, or sometimes remain the same over a period of time. If you think of it in terms of birds, there might be one bird in the tree, and then all of a sudden a whole bunch of them come to that tree. And then you'll see one fly off, and then you'll see a whole bunch of them fly off. So increase, decrease, or even remain the same. When population size increases or remains steady, it is often to be a sign of a healthy population. When population sizes decrease quickly, however, it can mean extinction is coming. We think about the idea of dinosaurs, they've been extinct. I believe if we look at, some things are on the verge of being extinct, such as the bald eagle. I believe butterflies were just done that they said that they were on the verge of being extinct. So that idea of extinction changes over time. Now, it's 2022. That's when this video has been created. So when I'm talking about the butterfly issue, that could be right here, right now. Population density describes the number of individuals within a population per unit area. So if we're talking about looking at the picture here, we're talking about some highly populated areas. If it's the darker it is, the more people that are in that area. If you only see white, there's not a lot of people. Many of you have heard me talk about my husband and when he had to live in Las Vegas. So right here in this corner where it's orange, that's Las Vegas. If you look out here in California, you can see the really dark red spots. Even over here toward New York, right around the tip right here of Lake Michigan. Over here on looks like the west side, that would be Chicago. So there's lots more people that live in there than what they're out in the Dakotas, Montana, Idaho, any of those. So you can see the population is how population density refers to the number of people living in the area. High population density can make it easier for organisms to group together or find mates. However, it can also lead to conflicts as individuals compete for resources. As you can tell, here at Concord, in 2022, our population of this school year is really, really high at the high school. There's about 1,800 students here, and it only continues to grow up because people continue to move into this area. And so now we're competing for resources. We're competing for spots here at the high school. Low population density can benefit organisms with more space and resources, but may find it harder to locate mates and companions. So if we're spread out even more, we might be able to hard to find people that we want to come in contact with. Populations can be distributed randomly, uniformly, or in clumps. So here, if you look at our picture, we're talking about this clumps of elephants. Notice how they're all right there together. It's so they remain safe, they interact, they mate, they care for their young. Okay. The middle picture talks about being uniform. So they're same spaces. Um, they can still have a chance to use their resources. And then, of course, you have random. Random when it's looking at like this thing of flowers, they aren't the same distance away from each other. They might be really close, and then they're farther apart on the next way. And so that is how the populations can distribute themselves. The egg structure of a population is an effective way to predict a population's growth. So here, if it looks like a triangle, okay, that's a positive growth. You notice we started off here at the bottom, and so there's a lot of people, and as you go up, which only makes sense. The older you go, the less people there are of that age group. Middle one, notice how they're kind of every line here is pretty close to being the same. So that's zero growth. That means it's a stable population. Um, Here for a negative one, notice how as the age increases, it's bigger than what it is when the age is smaller. So that would show that we have a shrinking population and it's a negative growth. All right. So there are your notes on population. And so hopefully you have filled out your notes. Please make sure that you turn those in, and I'll see you for 4.3.